I would like to discuss today about the soil retaining wall system. Particularly, this is one of the main structure which we will be using in geotechnical field and also in the construction many infrastructure projects. So, particularly when we are coming to underground structures, we have to have a knowledge on the soil retaining wall system. There are several types, and we'll be looking those things in the coming slides. So basically the presentation will be like initially it will be introduction, then we will be having a overview of the soil retention wall system and some basic fundamentals for the design of the soil retention system. Then I'll be discussing a case study which I have worked. It's a practical thing like project based. Then we'll be discussing about some job opportunities. So what is soil retention system? Soil retention system can be any wall or closed wall system which retains soil or other water retaining structures. Particularly structures that are built with, it can be a vertical or nearly vertical earth banks, particularly called as retaining walls. We have seen many retaining walls in our day-to-day life, and also like in retention system. There are several types of retention system which few people may be aware of that. Many wouldn't have gone through unless it is you are having some practical experience exactly knowing what is those retention system. Generally, some retaining system can be constructed of masonry or like concrete walls or sheet piles. Sheet piles nothing but with steel structures. As I said, that retaining wall system can retain earth, other than earth, it can retain water also. Generally, the soil retain system has to withstand some lateral pressures, that is either from the soil material or other material including the water pressure. So we will be going through those things in detail in the coming slides. So as I said, there are several types of retaining walls. The retaining walls, there is gravity retaining wall, hybrid type, it is a gravity wall supported by pile and that embedded retaining wall. Gravity retaining wall is nothing but a concrete retaining wall. Same retaining wall which is supported by pile is called hybrid retaining wall, and the third one is the embedded retaining wall. We are going to discuss about these embedded retaining walls in general because these are the structures which are most common and also used in the current infrastructure projects for the facility of underground constructions. So in the embedded retaining wall there are several types: sheet pile wall, soldier pile wall, contiguous pile wall, secant pile wall, and diaphragm wall. Generally, like sheet pile wall is a steel structure. Soldier pile wall is a combination of steel and then lagging system. Contiguous pile wall, secant pile wall, and diaphragm wall are like using the concrete. We will be building these walls. For selecting an embedded pile wall, first of all, we should be able to understand which type of wall will be suitable for the construction of a particular structure. There are different types of walls. We cannot use all the walls in certain cases. So we have to understand which type of wall will be suitable for the construction purpose for a particular project. So this plays a major role. Before selecting a wall, certain things are to be understood, like foundation of adjacent properties and services. So when we are going for underground construction, we should know what are the properties nearby to the constructions. What are the like piles or other structures, foundation footings nearby, so that we shouldn't affect the nearby constructions. Next is design limits on wall and retained ground movements. Design limits means settlement. How much settlement can be allowed on the wall, or the deflection can be allowed on the wall, and how much settlement is allowed for the projects. Generally, these type of constructions are done in urban environment. We cannot go over more settlements, so there is a limit for all the wall deflections. Next thing is we should understand what type of subsoil it is. what type of soil, because there are different types of walls and we cannot implement all the type of walls in different conditions. So we should understand which soil is suitable for which type of walls and the groundwater level. There is also limitations for the different walls. So certain walls are temporary and certain walls are not suitable for the groundwater conditions. So we should be aware of those things. So which type of wall is applicable for the conditions. And then working space requirements and site constraints. So while constructing certain types of walls, we should understand what is the working space available for the construction. Certain equipments are very big and we cannot be placed in the construction site. When it is, we have some constraints. So we should be able to understand what is the work space requirements, and based on that we should choose the exact working rigs, boring equipments, so that it can be useful for the excavation. Cost and time of construction. So in our civil engineering, everything depends on the cost. So how much cost we are able to save for the type of construction and the time of construction. The time is proportional to the cost. So whenever the time increases, the cost also increases. So we should be able to understand which type of method helps us to save time and also helps to save the cost of the project. Flexibility of layout of permanent works. So how much you can extend the permanent works, and then so most of the structures here, the wall we are seeing is mainly for the temporary structures also. So inside below that we are able to construct some permanent structure. So we should understand what is the permanent structures and their layout, everything. Based on that, this outside the structures are constructed. Local experience and available construction planning. So as of now, we know that whenever we are going to civil engineering projects, we should understand what is the local experience, like previously what type of walls are used. So based on that, we should understand certain things are like it can be worked out for the construction purposes. Maintenance of wall and support system in permanent condition. So there are these walls can be constructed in temporary cases as well as permanent cases. When it is a permanent cases, it is for a long-term duration for a minimum of 50 years. So you should be able to understand what is the maintenance for those walls and the support systems to be used for the permanent condition. So generally when we are constructing a wall, the main factor is the deformation. So the deformation of the wall is to be limited within a certain limit. So when we are working for urban projects, we should understand how much deformation has to be allowed. So for a particular type of construction, we should know what is the type of ground, what is the depth and width of the excavation, stability of bottom of excavation, and what type of support system can be provided in that for that is excavation, and rigidity of the wall and the construction technique. So when it comes to the type of ground, like certain grounds, when the ground is very stable and has very good amount of SPT value. So the ground itself is stable. So when there is a very loose ground, there is a possibility for the deformation. So this can be like for the low SPT N values. And for that factors, like the ground is very rigid also, like it has boulders. Certain conditions of walls cannot be driven, like for example in sheet pits. And depth and width of the excavation. Like depth of the excavation, like for certain type of walls, like we cannot go much deeper. So we have to go through for another type of wall, like which we are able to bore into deep. So normally we are in the range of 20 to 25 meters. We can bore walls like sick and pile wall, contiguous pier wall, but beyond that there is a vertical tolerance, so we should be careful. And like diaphragm walls have needs some special equipments to drive. Generally, for other walls like smaller, like soldier pile wall or sheet pile, or 10 to 15 meters is the maximum. Going through deeper is not practically possible. So embedded retaining wall is that one penetrates, and it has to be have some lateral support from the ground at base. Bending capacity of such wall typically plays significant role, and support of retaining material for the freestanding wall has to be maintained. We'll be going through like different types of wall we have seen. First, we'll be looking into the sheet pile wall. Sheet pile wall is a steel structure. Generally, it is used in many projects for the retaining. It's a temporary, mostly used as a temporary structure, but very rarely in cases. This is also used as permanent. I have seen somewhere in UK they have used this in permanent structure, but most of the time this is used as a temporary structure. Sheet pile wall is more like a economic wall, and this wall can be used for the water retaining structure, like particularly in projects, in ports project. Sheet pile is more common to be used for the construction of coffer dam, those things. As I said, this can be used as a temporary structure and permanent structure. And generally we have to look into, like for like when it is a coarse grained soil, like driving the pile is little difficult. So yeah, though the design is done for the lesser stiffness of the pile, still for the drivability cases we have to look into like how much drivable the pile is. So we have to look into the drivability case also for the stiffness of the pile. Generally there are two main common used is like U pile and Z pile. U pile, you can see in the picture like how the U pile is connected, and for the Z pile, the second one is the Z profile pile. Z profile pile is mostly used in the water retaining structures. It can be used like for many retaining walls, for watertight ceiling and watertight structures. These piles have normally for excavation depth of 15 meters, it is used like, but there are even cases where you can go up to 30 meters also. And that end bearing in coarse soil is very less, so we have to think about for coarse soils like which has very low SPTN values. When there is you have a deflection criteria like very less, then we have to be very careful. Like these piles tend to have large deflections. Generally, sheet piles is very common. These are like temporary structures where even in metro projects like construction of some ancillary buildings, those things they will be using. And the main advantage of sheet pile is that these are reusable. So after construction of underground structure, you can remove these piles and then you can reuse in the other constructions. So sheet pile is one of the most common sheet embedded retaining wall, which is used everywhere for the construction of the temporary, mainly for the temporary structures. Next is the soldier pile wall. Advantage of soldier pile wall is when there is an obstruction inside the construction area, still it can be adjusted and constructed. The one and the next advantage is like the drilling time is less, and practically sometimes there is no concrete, very less concrete is used for the construction. Here how the soldier pile is constructed is initially some I-beam structure is driven through. Actually it is bored, and the bottom embedded retaining system is filled with concrete to hold the driven structure. In between the structures and in the steel structures, the lagging is placed. The lagging can be a wooden lagging and it can be a concrete lagging. So there is a design for both wooden lagging for the steel I structure. One disadvantage for this soldier pile wall system is This cannot be used for the structures where we have groundwater. Like when there is a high groundwater, so the pile wall is not so common. This cannot retain water, and particularly when it is like coarse soils, the water flow will be very high. And this cannot be used for the construction of those coarse soils with high groundwater level. There can be potential ground movements in drained conditions. There can be safety issues with ground instability for clay filled with gaps, falling through the gaps. So some safety issues can be there, like sometimes the lagging can be falling down when it is not fixed properly. So these are the some limitations, but normally this is very easy for the construction, and most commonly this method is used in many places for the construction, even in metro projects. These are very commonly used structures for the, and if it can be, you can save more cost compared to other retaining structures also. Next, embedded retaining wall is secant pile wall. Secant pile wall is used in many projects, even for the underground structures, for the deep underground structures. This can be used both as temporary structure and also a permanent structure. There are three types of secant pile wall system. Is there like hard, soft, hard, firm, hard piles. Generally, the limitation for this is maximum you can go for like 20 to 25 meters of depth. Still, there is a limitation of vertical tolerance where because one pile and next to that another pile is bored, so there can be chances of movement, that verticality is not maintained for the piles. Generally, these kind of piles, for example, like when you are going for hard soft pile, this can be used as a temporary structure only most of the time. Sometimes it is used as a water retaining structures. This is not a permanent solution, but the soft pile mix is little bit costlier than the concrete. It is a mixture of like bentonite and concrete, generally in the range of like 2 to 3 MPa strength. The next is like hard form secant piles. This is more like a permanent retaining wall. You can use this as a permanent retaining wall. The firm material, I mean the firm pile, can be a strength of approximately 10 MPa cube strength. The verticality and also it has a depth verticality tolerance maximum you can go for 20 to 25 meters. Support fluids are required for drilling in silts and sands below water table. For deeper piles, you need railings for shear and bending to be transferred. Next is like permanent, hard and hard pile, which is also a permanent water retaining wall. This is also have a high stiff bending capacity. So these primary piles is also reinforced. I will say the difference, like initially how this is constructed is, first the primary piles is constructed. It is bored in intervals with the spacings, and then the secondary pile is constructed. Here like hard, soft, hard, firm or hard type means the first one, the primary pile, it can be soft, firm or hard. It means that generally it is sometimes without reinforcement, mostly for soft and firm. Only for the hard type, the reinforcement is placed. The reinforcement for hard type can be rectangular, not like a circular type just shown here. It is the secondary pile. It is the secondary pile. First, the primary pile is drilled, then the secondary pile, it has to be bored over the primary pile. Generally, the hard-soft interaction between the piles can be in the range of 150 mm. So for hard and firm thing, it can be in the range of 125 to 225 mm. Overlap is considered. You should have a boring equipment where This has to drive the primary piles. It has to cut through the primary piles, and then the secondary pile is constructed. Generally, the construction is done like initially in line, along the line of construction, the primary piles are constructed first, and then in between the primary piles, the secondary piles are constructed. For these construction, initially there will be a guide wall constructed at the top of the piles, I mean at the ground level. Then after that, to make the alignment perfect for the construction, then the primary piles are bored through. After that, the secondary piles are bored through, and the reinforcements are placed inside the pile. Or hard second pile, the primary and secondary pile can go up to a strength of up to M35 concrete. But in harder pile, cutting through the primary pile, you need high torque rigs to cut through the pile. Here also the vertical tolerance is one of the main thing, like it cannot deviate, like for longer depth the piles has a chance to deviate from the alignment. Compared to other piles, it is very slower because it has to deal through the main primary pile, so it has a chance to take much time compared to other earlier like hard soft or hard firm construction. And even for this construction, you need to have support fluids for drilling in seals and sands below the water table. The next embedded retaining wall is a contiguous pile wall. A contiguous pile wall is one of the cheapest and quickest form of construction, and but this is not a water retaining structure. There is no permanent solution because this is generally used as a temporary structure. This contiguous pile wall is nothing but a pile walls which is constructed at intervals with a spacing in between them. Generally, the clear spacing between the walls can be up to 150 mm. This cannot retain water because the gap between the piles, and most probably this will be used as only a temporary solution, not as a permanent solution. Because the gaps in between the piles, there is a possibility for the water flow, and for this also the construction during the boring you need support fluids, and for the transfer of the bending forces you need veiling. So we were talking about the temporary and permanent solution. Like there are cases like where the piles can be placed as temporary, and in certain cases the same piles can be used as permanent also. So for that, what we are seeing is diaphragm wall. Diaphragm wall is the one type of wall which we are using mostly as a permanent wall. In some few cases, we can use this as a temporary wall also. So when it comes to construction, like temporary wall is used for the excavation, like for the deeper excavation. Then the main structure is built over the in between. After it is excavated, the main structure is constructed in the place, and then slowly the temporary structure is removed for certain cases like sheet pile walls, those cases. But when it comes to diaphragm wall, this can be used as a permanent structure itself. Generally there are pop systems. We will be discussing those things, like it can be stuck and anchored. But when it comes to permanent system, the slabs are constructed as prop systems. So the same D wall can be used as a permanent structure wall. For a diaphragm wall, you can go for deeper depth, and very few joints are required for the diaphragm wall compared to other construction, I mean embedded retaining walls. But in the installation equipment is little bit of extensive. So when you go for small excavations like 10 meters for temporary cases, for very lesser depth, you no need to go for a diaphragm wall. Generally, like in most of our metro stations, underground metro station, diaphragm walls is the predominantly used in the construction, something like for the permanent walls. Like for other temporary cases, seek and pile wall is predominantly used. Uh, if it is there is no water table present at that location, contiguous pile is also used. In diaphragm wall, we can go for deeper depth. The verticality tolerance is also accepted. Sometimes when it is used for the permanent wall, the face of the diaphragm wall can form a final finish, and that can be used as a permanent wall also. Reinforcement for this diaphragm wall is like cage type. Generally, there are sizes like 800, 1200. So there are like even for like second pile wall, there is a standard boring sizes. With that only we can be drilling. So it's like even for here, like there are two types like grab and mills is used for the construction. So there are standard grab sizes for the construction of diaphragm wall. So those things are have to be looked into, like how much is the panel size, and when you go to like and the excavation is very deep, then you have to think about the weight of the reinforcement cage. So these things are also to be looked into when constructing a diaphragm wall. Here that one panel is connected to another panel after the excavation. So some water stops, those things are used for water where the groundwater is heavy. But for like main thing is that installation equipment is little extensive. So for like very large construction and for deeper construction, these type of embedded retaining wall is used. So can be economical for those things, but for lesser depth, this type of construction is little bit costly, and you cannot go for this type of embedded retaining wall for those cases. So when it comes to diaphragm wall itself, like even it can be like top down and bottom up construction. Generally for permanent cases we can go for top down, like temporary cases this can be bottom. Top down means while like after constructing the wall, the excavation is done from top, and we will be placing the permanent slab at the top. For example, in the metro cases, we will be constructing a roof slab, then we will have a hole in the slab, then further equipments are placed inside and further excavation is carried out. Then we will go for concourse slab, then it is base slab. So the slab itself is used as a top system. So this is a top down construction. This can be used for metro stations. And when it comes to bottom up can be even a permanent or a temporary solution. For generally for temporary cases, it is fully excavated through like different level of propped studs or anchors. Then the bottom of the excavation is reached. From there, then the permanent structure is constructed from the base slab level to the top. But for the like larger excavation, there will be a plunge columns or barrette piles constructed in between the width of the excavation to for the construction of slabs, everything. So this diaphragm wall can be used like both like an permanent wall and a temporary wall, and this is more predominantly used for deeper excavation. It can go up to depth of 50 meters also. So this is one of the best construction for embedded retaining wall for deeper depth of construction.